Okay, this is a video that will show you how to add and subtract these three fractions. Okay, as you can see, the denominators are relatively big, and there are three obviously. Okay, and hope you know that in order for you to add and subtract these three, you do have to come out with least common denominator. Okay, so let's go and look at how to find the least common denominator, or we call that LCD, of these three. So I'm going to revert to another sheet and we're going to come back to this. Okay. So same fractions, and as you can see, it says that LCD of those three is the LCM. LCM stands for least common multiple, okay, of the three denominators. Okay, and that's no trivial matter. Okay, so what we're going to do first, the way we find the LCM is that we do need to do what is called prime factorize all three. So let's begin with that. 24. Okay, some of you may have seen this as a tree. 24 can be broken down by prime numbers as 2 and 12. And when it's a prime, I put a circle saying that's the end. Can't really break down 2 anymore. 12, 2 and 6, 6, 2, 3. Okay, so there we have the prime factorization of 24, which now will give us as 2 times 2 times 2 times 3. And I'm going to write this as 2 cubed times 3. Here the exponent will play an important role. Okay, let's continue this for 18 and 15 as well. Okay, so 18 can be broken down as 2, 9. 2 is prime, 9 is 3, 3. Therefore, 18 is 2 times 3 squared. Okay, and the final one is 15. 15 is the final one, and 15 is just 3 and 5. Okay. So there we finish the prime factorization of the three. Okay, so let's look at this. Okay, so 24 we wrote it as 2 cubed times 3, 18 as 2 times 3 squared, 15 as 3 times 5. Okay, so that's the prime factorization of the three denominators. Now what we do is we solely just concentrate on these three. We don't really need this anymore. And we are going to list what are the three prime numbers, or all the prime numbers we use to prime factor all these three numbers. And if you look at carefully, we only use 2, 3, and 5. Those are the three prime numbers we use. There are no others. There is no 7, there's no 11, no 13. These are the only three. Now, underneath these, what we're going to do is attach the highest exponent that we see for each of the three prime numbers. For example, for 2, well, the prime number 2 occurs twice, 2 to the third power and just 2 to the first power. Obviously, this third power is a higher exponent, so we are going to attach cube. Prime number 3, it occurs these two places. Obviously, the 3 square has a higher exponent, so 3 square. 5 occurs only once, and of course we don't write it, but there's a hidden exponent, 1. Okay, now with these three, what we're going to do is form a product, meaning we're going to multiply these three, which will be 8, 9, and 5. If you multiply those two, which is 72 times 5, that will give us 360. This is your LCD. Alright, so that is the LCD of these three fractions, which is same as the LCM, the least common multiple of 24, 18, and 15. Now I know this whole thing looks pretty long, and it's not short, but it is still faster than if you were to sit down and list all the multiples of these three until you come out with 360. That will take you much longer. Okay, then back to our problem. Remember, our problem started out with this, which is adding and subtracting these three. Now what we just found is that 360 is our LCD. So we do need to write each fraction as its equivalent fraction with these three new denominators. Okay, so 5/24 can be written as some numerator divided by 360. And the basic question we ask is 24 times what number will give us 360? And the answer to that is times 15. Okay, you can do that by dividing 360 divided by 24. That will give you 15. And this multiple 15 needs to multiply our numerator for the 5. Okay, and we repeat this process. 18 times 20 will give you 360. So that 20 needs to multiply the numerator 7. Okay, and finally, let me write down this way. 15 times 24 will give you the 360. Therefore, we have to multiply the numerator 4 by this multiple 24. Okay, so hope you see where each of these new multiples times 15, times 20, times 24 comes from. Actually, we are almost done here. All you have to do is now multiply 5 times 15 gives you 75. 7 times 20 gives you 140. And 4 times 24 gives you 96. So only thing we are left to do is just add 75 plus 140, subtract 96. And I can do that. Sometimes I'll write a big single fraction with 75 plus 140 minus 96. Okay, and if you do this addition and subtraction, what you end up with 119 over 360. Okay, now I know when the numbers are fairly big like this, you probably want to check, gee, I wonder if this can be reduced. Okay, in this case it's not. This is the simplest form. Alright, so there you have it. Okay, so that is your final result. Again, the process is longer than what's shown here, mainly because of earlier what I went over how to find the LCD of those three. Okay, and again, the process is kind of long because this problem got three fractions with denominators that are relatively big. Okay, so that's it for this problem.